Hello students, welcome back to Organic Canvas. We have seen how to represent organic molecules in the last video. In this lecture, let's see how to classify the organic compounds. So let's get started. The broadest classification of organic compounds is based on the arrangement of their carbon atoms, whether they form straight or branch chains or closed ring, or you can call them as cyclic compounds. This creates the primary division into acyclic and cyclic compounds. Students, remember here we are going to classify these organic compounds based on the carbon-based molecules. Why is it so? Because in the first lecture we have seen that due to the special properties of carbon, it's going to form millions of compounds, right? So it can be due to the electronegativity of carbon, the tetravalency, hybridization, isomerism, etc. That's why we are going to take these carbon-based molecules, right? We will systematically classify them and then study. That way it would be easier to study the organic compounds. So let's see what are acyclic or open chain compounds. So open chain means what? They will be a straight chain of molecules like cyclopropane. So now you know it's a bond line structure. This is what we have learnt in the previous lecture, right? So this is a propane molecule. We can have butane. You see, they are straight chain of the molecules. You can even have a branch, no problem. But when it comes to cyclic, they are in a closed chain. That means a carbon will form the bond with the other carbon and they are in a closed format like this. A cyclopropane, cyclobutane, or even cyclopentane, and it goes on. So acyclic means open chain. You will have two terminal carbons like this, right? But here there is no terminal. They are in a ring form. So that's why these are called as closed chain, right? Now let's classify the acyclic compounds further. It can be classified as saturated and unsaturated. If the molecules have only sigma bonds, then we call it as saturated. So the best examples are alkane molecules. For example, let's take methane or ethane, right? You see there are only sigma bonds in them. So they are considered as completely saturated. We can even write like propane, butane, etc. So these are some of the examples for saturated molecules. Alkanes are the saturated molecules. They have carbon-carbon single bond in them. Okay, now let's move on to unsaturated. Unsaturated molecules will have pi bonds in them in the form of a double or a triple bond. So the best examples are alkenes and alkynes. Alkenes like ethene, ethine will have pi bond. You see there is one pi bond. Here there will be two pi bonds. So due to the presence of the pi bond, we call them as unsaturated. Okay, so ethene, ethine are the examples for unsaturated molecules. Now, let's see what are cyclic or closed chain compounds. As I was telling earlier, there won't be any terminal carbon here. So the carbons are linked to each other, right? Like in this fashion. So we call them as cyclic molecules. The cyclic molecules further classified as alicyclic compounds and aromatic compounds. In order to understand this, I will give you a simple trick. What is that? The aromatic compounds are anything which have a benzene structure. Benzene is a cyclic molecule where you see alternative double single like this, right? So aromatic compounds are the one with the benzene or benzene-like structures. Their properties will be similar to that of the benzene. Then we call them as aromatic compounds. Anything which is cyclic but not aromatic, then we call it as alicyclic compounds. So what will be the properties of these alicyclic compound? It will be similar to that of the saturated and unsaturated acyclic molecules. Okay. These are ring structures, but their properties will be similar to that of the acyclic molecules like the saturated and unsaturated compounds. For example, cyclopropane. Right. For this, I'm going to write here cyclopropane, cyclobutane, cyclohexane, cyclopentane, all these are alicyclic compounds, whereas aromatic compounds are similar to that of the benzene or benzene-like structures. All right. So we'll discuss this in detail, but first let's see how to classify the alicyclic compounds first. If all the atoms in the ring, they are carbons, then we call it as homocyclic. So all atoms are carbons, then we call it as homocyclic. Homo refers to same. Okay, so that's why homocyclic. Like for example, you have written the condensed structures like this, right? So it's nothing but there are 3 carbons and it is cyclic, therefore cyclopropane. You can write some more bond line structures like cyclohexane. All of them are carbon, so homocyclic. If there is one atom which is not carbon like nitrogen, oxygen, sulfur, then we call it as heterocyclic. For example, if there is an oxygen like this, these two are carbons, but this is oxygen, and then we call this molecule as epoxide. Like this, we can even have nitrogen, sulfur, etc. Say we'll write 5-membered. It can be 3, 4, 5, 6-membered also. So I'm going to write a 5-membered ring, which is heterocyclic because of the oxygen. And the name of this molecule is tetrahydrofuran. THF, tetrahydrofuran. Okay, so these are heterocyclic compounds. Now, coming back to aromatic compounds, they are most of the time 6-membered ring. Okay, they have pi electrons where they are alternative to each other. Okay, and if they have benzene in them, we call them as benzenoids. Okay, they don't have this 6-membered ring, but it behave like a benzene, then we call it as non-benzenoid. Okay, let's take for example benzenoids. Benzene, you can even write it as a ring. Okay, ring also. Okay, you will learn this very soon why we write it as a ring. You can either write it as alternative double single or as a ring. Okay, so anyway, benzene, toluene, and then you can even have other atoms also like this. Okay, here nitrogen is not part of the ring. Okay, it's outside, so still it is a benzene molecule. So this is called as aniline. Now what are non-benzenoids? Non-benzenoids, they behave like aromatic as I told earlier, but they don't have any 6-membered ring. See, this is 7-membered, 1 2 3 4 5 6 7 attached to a 5-membered ring like this. And then you write alternative single double bond. You can write anywhere. Okay, here you can start double, single, double, single, double, single, double, single, double, single, double, it goes on. So such molecule, the name of this molecule is azulene. It's neither 6-membered ring, right? So it's not a 6-membered ring, but it is having a 7 and 5, but it will behave like a benzene. So that's why we call it as a non-benzenoid molecule. Like this, there are many other examples. As you go on, you will learn all this. So why do we have to do this classification, students? Because you already know there are millions of organic compounds. So learning each and every molecule becomes very difficult. So that's why you classify the organic compounds like this, and then it would be easier for you to understand their structure, their properties, etc. So in the next class, we are going to learn some more basic concepts of organic compounds like what are functional groups, what are homologous series. Thank you for watching this video. Until next time.